Hey everyone, I am Crystal K. Latina and I am here to tackle to you the computing compound interest rate and time period of lesson 2 in module 2. So, compound interest rate is the addition of interest to the principal sum of a loan or deposit, or in other words, interest on principal plus interest. The nominal rate cannot be directly compared between loans with different compounding frequencies. Both the nominal interest rate and the compounding frequency are required in order to compare interest-bearing financial instruments. So let us now move to the derivation of the formula. So let us derive the formula of nominal rate in the compound interest formula. So F is equals to P to the quantity of 1 plus I to the power of N. So here we first replace the nominal annual interest rate in percentage terms by nominal rate over periods per year. So F is equals to P to the quantity of 1 plus G over M to the power of N. So the next we divide both sides by P. So F over P is equals to the quantity of 1 plus G over M to the power of N. Next, we extract the N root of both sides. So N square root of F over P is equals to the quantity of 1 plus G over M. Then the next one, we subtract both sides by 1. So N, the square root of F over P minus 1 is equals to G over M. Then we multiply both sides by M. So M to the quantity of N square root of F over P minus 1 is equals to G. So now here we have the formula for nominal rate. J is equals to M to the quantity of N square root of F over P minus 1. So what is compound interest? Compound interest is the interest of savings calculated on both the initial principal and the accumulated interest from previous periods. So interest on interest, or the power of compound interest, is believed to have originated in 17th century in Italy. It will make a sum grow faster than simple interest, which is calculated only on the principal amount. How compound interest works? Compound interest is calculated by multiplying the initial principal amount by 1 plus the annual interest rate raised to the number of compound periods minus 1. The total initial amount of the loan is then subtracted from the resulting value. Compound interest schedules. Interest can be compounded on any given frequency schedule, from daily to annually. The commonly used compounding schedule for saving accounts as bank is daily. For a certificate of deposit or CD, typical compounding frequency schedules are daily, monthly, or semi-annually. For money market accounts, it's often daily. For more mortgage loans, home equity loans, personal business loans, or credit card accounts, the most commonly applied compounding schedules is monthly. There can also be variations in the time frame in which the accrued interest is credited to the existing balance. Interest on an account may be compounded daily but only credited monthly. Compounding periods. When calculating compound interest, the number of compounding periods makes a significant difference. The basic rule is that the higher the number of compounding periods, the greater the amount of compound interest. Interest rate formula. Using the interest rate formula, we get the interest rate, which is the percentage of the principal amount charged by the lender or bank to the borrower for the use of its assets or money for a specific time period. The rate a bank pays to its depositors for keeping money in a saving account's recurring deposit or fixed deposit is also termed as the interest rate and in this section we will discuss the interest rate formula. So here's an example of computing compound interest rate. The maturity value of a 5-year 7,000 pesos compound interest investment certificate was 9,427.99 pesos. What quarterly compounded nominal interest rate did the investment certificate earn? So here's the solution. Given the time, 5 years, principal amount 7,000 pesos, future amount 9,427.99 pesos, periods per year is 4, then the number of compounding periods, which is time multiplied by the period per year, is equals to 20. So J is equals to m to the quantity of n square root of f over p minus 1. The value given is 4 to the quantity of 20 square root of 9,427.99 over 7,000 minus 1 is equals to 4 to the quantity of 20 square root of 1.346855714 minus 1 is equals to 4 to the quantity of 1.015000027 minus 1. So is equals to 4 times 0.015000027 is equals to 0.06 or 6%. So the nominal rate is 6% compounded quarterly. Computing the time period. The most challenging part in compound interest is calculating the numbers of years to come up with the expected amount. The computations involves the use of logarithms. Most of the time, calculations for years are applied when determining the time when the amount invested will double or triple itself. Here are things to consider in order to get the total numbers of periods. Future amount, principal, nominal rate of interest, and number of periods per year should be given. Next, divide the future amount by the principal amount, and the last one is transform the equation into logarithm form. Here's an example for computing time period. So how long will it take an investment earning 18% compounded monthly to double in value? So here's the solution. Given the nominal rate 18% or 0.18, periods per year is 12, then the nominal annual interest rate in percentage terms is 0.18 over 12 is equals to 0.015. So time is equals to logarithms f over p over m to the quantity of logarithm 1 plus the nominal annual interest rate. So it is equals to logarithm 2 over 1 divided by 12 logarithm 1 plus 0.015 is equals to 0.3010 to 99957 over 12 times 0.006404225 is equals to 0.3010299957 over 0.07759250069 is equals to 3.8796227136 is equals to 3.88 years. So the total time is 3.88 years. So here's the ending of my topic. Thank you guys for listening. God bless.